Let me just open it from here, okay? Hello? Yeah, it just started recording. Yeah, okay. Hello, my name is Revant Reddy Devana, and I am from Group 7 in Machine Learning class. So here we are gonna discuss about our recent research report on enhancing decision trees with large margin heuristics. This is a report we have developed, we have created by taking this paper from IEEE. Let me just show you the paper. This is a paper we have gone through, and our team and everyone.
Just a second. I think you are not
Am
sharing.
I not sharing the? Okay.
Yeah.
Just a minute. I'll just. Thank you, Akanksha. Yeah, I was not sharing the video. Now, coming back to this, this is a paper we were talking about the new heuristic of the decision tree induction. So this paper we were researching about, and we were analyzing it and making the report on it. So we have made these are the following contents we have created. Executive summary, methodology. First of all, let me introduce our group. My name is Revant Reddy Devana and Avinash Reddy Berdala, Akanksha Survey, Darshak Sembeti, Rishita Reddy Kasreddy, Shakira Tapasum, and Lu Zhang. So we are 8 members in our group, and we are from group 7. So these are the contents from the report, from this report. Executive summary, introduction, methodology, decision tree induction, which is the traditional approach, and the paradigm shift, large margin heuristic, experimental methodology, and finally we are going to discuss about the conclusion. Now my friend Avinash is gonna continue from here. Avinash, you can go ahead.
Thank you, Revant. As when it comes to executive summary, this comprehensive research report explores a groundbreaking approach into improving decision tree induction, as introduced in the paper. A new heuristic for decision tree induction by Ling Li and Li Jiao, Ai Xia Chen, King Yu Meng, and Gu Huang Zhang. By leveraging large margin support vector machines, which is SVM in short, the paper offers a new perspective on decision tree generalization. Our through analysis encompass the proposed methodology, experimental results, and the potential implications for the future research. So this is about executive summary, and I'll pass it back to Revant for further discussion.
Yeah, coming back to the introduction, in this we have the background and motivation behind the introduction is the decision tree induction is well-established technique for extracting classification knowledge from sets of feature-based instances. However, traditional heuristics, particularly the minimum entropy approach, possess inherent limitations in terms of generalization. This paper investigates a decision tree generation procedure to improve the generalization capability of existing decision tree programs based on the minimum entropy heuristics. Due to the relationship between the margin of SVMs and the generalization capability, the split with maximum margin is considered as a new heuristic information for generating decision trees. In the process of induction, the inverse problem of SMVs is required to be solved. Compared with the decision tree programs based on minimum entropy heuristic, the training accuracy and testing accuracy has been improved. The paper under consideration addressed these limitations by introducing a large margin SVM as a heuristic source, aiming to enhance decision tree induction's generalization capabilities. Coming to the objectives and scope, this report aims to comprehensively analyze the novel large margin heuristics proposed in the paper, the overarching objectives are to gain a deep understanding of the large margin support vector machines as a heuristics for decision tree induction, scrutinize its empirical effectiveness through experiments, and elucidate its potential impact on the broader field of machine learning and data analytics. From here, my friend Vikas will continue. Vikas, you can take it on.
Thank you, Revan. So I'm going to discuss about the methodologies used in the report. So the first one is data collection and preparation. The study is based on a collection of diverse data sets, including iris, rise, PIMA, and image segments. To ensure the data sets are aligned with the research requirements, pre-processing is performed. And the second one is methodological approach. The analytical approach encompasses various methodologies, notably large margin SVM, clustering, and decision tree induction algorithms. Thank you, Revan. Back to you.
Yeah. We are discussing about the decision tree induction, which is a traditional approach in this one. In this session, we lay the foundation by providing an in-depth explanation of the traditional decision tree induction process, which relies on minimum entropy heuristics. We delve into the strengths and limitations of this conventional approach, setting the stage for the introduction of the novel heuristics. Coming to the paradigm shift, which is a large margin heuristics, this session explores the central concepts of the paper, the large margin heuristics. We dive into the relationship between the support vector machines and their impact on the generalization capabilities of decision tree induction. We explore how maximizing the margin as exemplified in the SVM framework can serve as a novel heuristics approach to enhancing decision trees. The main idea here is due to the high generalization capability of SVMs, we can apply the SVM's inverse problem to the decision tree induction process. We construct a decision tree in the process of maximizing the margin of each split for a given training set. Initially, we do not consider its class labels. The data set can be split into two subsets by solving the inverse problem of SVM. The subsets can be considered as a new branches. The instances labeled with -1 can be considered as the left branch, and the instances labeled with +1 can be considered as a right branch. The hyperplane function with the maximum margins is recorded. It is used as a decision function. When we classify the new instances, the outcomes of the decision function will decide the branches they belong to. If the outcome of the new coming instances is less than 0, it belongs to the left branch, else it belongs to the right one. The algorithm here is the process outlined in the research involves the induction of a decision tree based on numerical attributes and specified truth level threshold denoted as beta. The main steps are as follows. The step 1 is a root node is created to include all instances in the training set. These instances then divided into two subsets as a new branches. When coming and employing an approach that solves the inverse problem of SVMs, the hyperlane with the maximum margin is recorded at this root node. In step 2, for each branch originating from the root node, the proportion of objects belonging to each class are calculated. If the proportion exceeds the given threshold, beta, then the branch is terminated as leaf. If not, the branch continues to be split using the method from the step 1. The above procedure in step 2 is repeated for all the newly generated decision nodes until no further growth is possible, signifying that the decision tree is complete. For a two-class problem, the algorithm named maximum margin is designed to handle this process. It takes the training example set and the threshold beta as input and returns a decision tree capable of correctly classifying the provided examples. The decision tree's root node is created and based on the proportion of positive and negative class instances, it is either terminated with a positive or a negative label or further split into two branches. using SVMs, inverse problem to fix the maximum margin. This process offers a structured way to construct a decision tree that is optimized for classification with the added benefit of generalization. Now, Rishita will continue from here. Rishita, you can take from here.
Yeah. So coming to the experimental evaluation and discussion, in the experiment and decision, the authors applied support vector machines to decision tree induction, specifically using a maximum margin as heuristic to induce the decision tree. This approach was compared to another method that used the minimal entropy as the heuristic. Both methods were designed for data sets with real data types, and two decision tree induction systems were implemented. To conduct the experiment, the author selected data sets from the UCI database, including IDs, RISE, schema, and image segment, each with unique features. The experimental steps were as follows: data processing. The class attribute of the data was transformed into binary labels -1 and +1, and the heuristic and the data set was randomly divided into 70% of training set and a 30% of testing set. Setting parameters, specific parameters for the algorithms were defined as listed in the table 2. Training, the data were trained using the induction algorithm based on a large margin, resulting in the creation of the decision tree. Testing, the testing data were used to evaluate the testing accuracy. The results indicated that using the maximum margin heuristics improved both training and testing accuracy compared to the minimal entropy based approach. This suggested that the generalization ability of the decision tree induction process was enhanced to some extent by maximizing the margin. The concept of margin central to the success of classification learning algorithms plays a significant role. The authors highlighted the increasing the margin has been shown to enhance the generalization capability of SVMs, and the induction process, which uses the maximum margin as the heuristic, was successful in achieving this goal. This experiment evidence supports the effectiveness of incorporating the maximum margin heuristics in the decision tree induction process, ultimately improving the generalization capability of the accuracy of the model. And coming to the conclusion, in order to generate decision trees with higher generalization capability, this paper proposes a decision tree induction algorithm based on a large margin. The clustering algorithm for solving the inverse problems of SVMs is chosen during the induction. The main disadvantage of this algorithm is still its large time complexity. Practically, it is expected to give an improved version and another algorithm with time complexity reduction. Thank you.
Yeah, thank you, Rishita. So this is a paper we will discuss. This is a final report we have created after going through the research paper. So I'll just show you the research paper here with the following algorithms and the formulas. So I'm gonna link this paper. I'm gonna upload this paper as well in the submission form so that it will be visible to the professor. Okay. So we were talking about after going through all this paper, we have just analyzed the report and we have got those points. Thank you everyone. So this is our final report from a new heuristics of the decision tree induction. These are the authors. Thank you. Maybe we can stop the video now.
Thank you.
Can anyone stop the recording?